we have completed the buggy lab. You should have that lab written up and in your notebook, and what we're going to do is kind of tie things together and transition from the buggy lab into what we're doing next week. And we're going to be talking about motion graphs, and that means graphs of position versus time. So here's kind of what we want to accomplish. First, we want to define position, time, and velocity much more quantitatively than we did before. We want to use a linear graph to determine the position, time, and velocity of an object. And we want to determine the velocity, meaning the speed and the direction of an object, and the initial position by looking at a graph. And finally, if we have graphs where we're given position and time, but we're not given numbers, we want to actually describe in plain language what the object is doing. Alright, so let's go ahead and review our definitions. Some of these will be new and some of these will be review, and we're just going to go ahead and just set them up. So the first definition, of course, is position, and I'm just going to shorten it. What I'm going to basically say is position is the coordinate of an object with respect to a reference point. And let's just remember, and I just want to actually kind of make the note here that for us, in the buggy lab, this was the meter stick 0. So 0 centimeters on the meter stick. That was our reference point or our origin. And pretty straightforward. Now the initial position, that is the starting point of the object if it's moving. And so in the first, just to kind of refresh your memory, in the first part of the buggy lab, what actually ends up happening is that we end up getting that with the buggy lab, we get in the first part that the reference point is the initial position in the first part. In the second part, we actually get that the origin or the reference point is 1 point, and x naught, the initial position, ends up being somewhere between 80 and 100 centimeters. And I know some of you actually were bold and said, you know what, the buggy moves too fast, so we'll make it 200 centimeters. So that's really, really an important point. Now, the next thing, of course, is time. Time is basically, we don't really define it, we just say we measure it using watches. Okay, that's how I'm going to leave that. Now, from the buggy lab, what you should have learned is that velocity is measured in meters per second, and what it basically is how fast you go and in what direction. And what we're going to, and what we kind of learned from the buggy lab is, it is the slope of the position. It is the slope of the x versus t plot. So that's kind of the more rigorous definition. Now notice slope can be positive or negative. So the what direction actually means that's the positive and negative part. So if you've got a positive slope, you're going forwards, and negative slope, you're going backwards, and you should see that from the buggy lab graphs. We'll actually kind of review the results of those in a second. And then for speed, it's simply how fast you go. Now, we'll actually get a little bit more clear on this in a second. So right now, we're talking about how fast you go and in what direction, and speed is simply how fast you're going. We're going to distinguish this later on. The buggy lab that we're talking about, there's actually a very special name for this particular kind of speed and velocity, but we're not going to actually worry about that right now. So those are the basic definitions, and when I say, again, slope of the x versus t plot is the velocity. If you have a positive slope, you've got positive velocity. If you have a negative slope, you have negative velocity. So what I want to kind of get to next and sort of reinforce next are a couple of things that will be a little helpful to us in understanding the graphs and the buggy lab that we did last time. So let's kind of review just a few results here. The first thing I want to distinguish is maybe some of the graphs that you might have got when you were doing the buggy lab. So for example, When you did your very first part of the Buggy Lab, what you probably saw was you had a plot that was really simple and straightforward. In fact, I like this thing so much I'm going to copy it because I'm going to do two things with it. Okay, and we're just going to kind of qualitatively reinforce some ideas here. Paste it here. Wonderful. So we'll move that down here. So part one of the Buggy Lab, everybody should have got a very simple graph where you start here and then you just kind of go off in a straight line like that. And you probably had your different points in the Buggy Lab, and it's all kind of, and you get the slope. Now, let's be clear on a couple of things. First of all, the 0 mark in this case is two things. First, it is the origin or the reference point. And some people were very clear about this, and this is awesome. They were also able to say, you know what? Not only is it the origin, it also happens to be the initial position x naught. So this is kind of how part one worked out. Okay. When we did the second part of the Buggy Lab, you start off at some higher position. I'm going to say it's 80. And then you notice you go backwards and backwards and backwards towards the origin, and you get a linear graph that looks like that. Let's be clear. There, your graph looks like this, and there are a couple of different things here. First of all, the first thing that we need to take note of is now we have a difference between the initial position and the origin. X naught is right here at 80 centimeters. And this is the initial position where you start. And that's exactly what this definition here is. Now, this here is still the reference point. It's still the origin. And again, the idea is that you actually have a meter stick, right? It's a horrible drawing of a meter stick. And you have a buggy. So this is my attempt to draw a buggy. Very bad drawing. And what's happening is the buggy rolls this way. So it starts off here at 80 and is going towards 0, the origin, the reference point. So this is x naught, and this is simply the reference point, and the buggy goes that way. So that's one very important point. So this is all kind of qualitative graph stuff, not very much with numbers. Now, the important thing that you really should have got from this Buggy Lab, when you look at your definition of slope, the slope of this line is the velocity. And we said slope is rise over run. Well, if you notice the units of rise is meters, the units of run is seconds. So what you actually get, and also here, slope m is the speed. So what we get is the slope is rise over run. In other words, when you calculate that number, the slope, v naught, this is kind of the new idea. It is, in fact, the slope of the x versus t plot, which is just what we wrote here. Okay? If you have a positive slope, you have a positive velocity. Now, the interesting thing here is if you could actually take this and write, using that knowledge of slope-intercept form, how would you, in fact, write this equation as a linear equation? Well, you know that you have y equals mx plus b as the normal way of writing equations, and now we have a new way of doing this based on the graph. So first of all, what y is the y-axis is the position axis. That should be an x. So actually this is y. So y versus x. So what is y? We're now going to call it x, which is position. So in fact, I'm going to actually go ahead and replace this. I'm going to replace this letter y with the letter x. So just get rid of this. And so what we have is here, this letter here is going to be a nice big fat x because we replace it. And here, instead of this being the x-axis, it is now the time axis. So we've got to replace a couple things. So the first thing we replace is we take this y and we write it as x. We take this x and replace it as t. Now, the slope, we said, is the velocity. So what that means is this is v naught. And finally, B. Well, B is your y-intercept, which is where you cross the y-axis, which is right here, and that's actually your initial position. So for this last problem, we're going to do actually an example problem that's kind of the kind that you'll see on an exam and on a lot of homework problems. So basically, we have an object that's moving, and the way it's moving isn't quite like the buggy lab. It actually changes from moment to moment. It changes quite a bit as it's traveling. And what we want to do in part A is describe qualitatively what the car is doing. What that means is tell me, is the object moving forwards, backwards, speeding up? Well, it's not speeding up or slowing down. This is constant velocity, but is it sitting still sometimes? And so we're going to label all that now. So from 0 to 2 seconds, we move forward at a constant velocity. Then from 2 to 6 seconds, if you notice, this is actually very tricky. What's happening when you actually look at this, and you know what? I don't want to change this. So from 2 to 6 seconds, this is very interesting when you actually look at this right here. We notice the slope is 0. When we have a 0 slope, because the line's flat, that means we have no velocity here. So what that means is that from 2 to 6 seconds, in fact, what's happening is we don't move. Then, from 6 to 8 seconds, we move forward at a constant velocity faster than from 0 to 2. From 0 to 2 seconds. The reason I know that, the line is steeper because I have a steeper slope. Finally, and that's, sorry, not from 6 to 8 seconds, that's 6 to 7 seconds. My bad. And from 7 to 13 seconds, what actually happens is we move, sorry about that. From 7 to 13 seconds, we move backwards towards the reference point at a constant velocity that is faster than from 0 to 2. Sorry. That is actually slower than from 0 to 2. And I can actually tell that by doing a calculation. You can check that for yourself, but I'll tell you, this is the process that you actually have to do to calculate the slope, as in part B. So they ask us for the slope. Now there's two ways we can do this. We can do rise over run. And what that means when we do rise over run is that we are actually going to do a calculation where we go up by the rise and over by the run and up by the rise. So I go from here to here. So that's 1. And I go 1, so I go up from there 1, 2, 3, 4. So rise over run ends up being 4, and the units are meters per second. Now, somebody said that rise over run was confusing, and they said it's because I couldn't remember which is which. That's not confusing. That's called lack of practice, okay? So what you need to do is memorize that by practicing again and again and again. Okay, so be very careful about that. Now, that's rise over run. Now, another way to do this, of course, is with the coordinates method. So if you notice, I can look at my coordinates here. I'm at 7, 7. And here, this point ends up being 6, 3. So then I can actually do y2 minus y1 over x2 minus x1 to get the slope. And that's going to end up being 7 minus 3 over 7 minus 6. And that ends up being 4 over 1, which is also 4 meters per second. So you're expected to be able to do both of those in class. That pretty much wraps up what we're doing.